Hello students, so today we will solve this CBSE Chemistry 2022 question which has 4 parts and we will solve each of them one by one. So let us start with the part 1 of the question which says calculate the overall order of a reaction which has the following rate expression. So let us write the rate expression for the reaction given as rate is equal to K times A raised to the power 1 by 2 and B raised to the power 3 by 2. So here the order of the reaction with respect to A is 1 by 2 and with respect to B it is 3 by 2. So overall order of the reaction will be the sum of the order with respect to A plus sum plus order with respect to B. So it is 1 by 2 plus 3 by 2, that is 4 by 2, and it is finally 2. So overall order of the reaction is 2, or it is a second order reaction overall. Now let's come to the second part of the question. Second part of the question says what is the effect of temperature on the rate of reaction. So if you know the Arrhenius theory that says that when you increase the temperature of the reaction mixture, the average kinetic energy of the molecules increases, and if molecules have more kinetic energy, then now more number of collisions will result into product formation. So at higher temperature more product will be formed, or you can say that the reaction rate will increase. So what you will write, rate of reaction increases on rising temperature. So this is the answer to your second part of the question. Now let's come to the third part of the question. Third part of the question says what is meant by rate of reaction. So what is rate of reaction? Rate of reaction is the speed at which reaction takes place, and it is equal to the rate of change of concentration of reactant or product divided by their stoichiometric coefficient present in the balanced reaction. So what does that mean? Suppose we have a reaction AA plus BB that results into CC plus small d into D. Okay, so this is the reaction which is balanced. So for this reaction, what you will write, the rate is equal to rate of change of concentration of the reactant or product. But as with respect to time, the concentration of reactant decreases, so we use minus sign here. So minus dA divided by dt. So this is the rate of change of concentration of A, but you have to divide it by the corresponding stoichiometric coefficient. So it will be minus 1 by A dA by dt. Similarly, this will also be equal to minus 1 by B dB by dt. So it doesn't matter in what term you represent the rate of the reaction, you can represent it in terms of reactants as well as in terms of product. So for products, the rate of concentration change increases with time, so it will be positive. So for C you will write is equal to 1 by C dC divided by dt, and for D similarly it will be 1 by small d dt divided by dt. Okay, so this is third part of the reaction. Now let's come to the fourth part of the question. Fourth part of the question says a first order reaction takes 77.78 minutes for 50% completion. Calculate the time required for 30% completion. They have given the value of log 10 as 1 and log 7.8450. Okay, so they say that time taken for 50% completion, so that means T half they have given, and it is a first order reaction. So T half is 77.78 minutes given, and you have to find out time taken to complete the reaction by 30%, what it will be, and they have given log 10 as 1 and log 7 as 0.8450. So let us see how will we solve this question. So if you know the formula, the rate expression you get for first order reaction, that is T is equal to 2.303 divided by K and log initial concentration, suppose I say that is R naught, and divided by final concentration, that is R after time T. So let's put the values here, 2.303 divided by K. So if you know the half-life of the reaction, then you can calculate the rate constant. So rate constant will be 0.6931 divided by half-life, so it is 77.78 minutes given in the question, into log, let's put the value R naught, initial concentration, suppose that is R naught, so reaction is getting completed 30%, That means the final concentration will be how much? 30% completion means 30% of the reactant will get into product. So how much reactant will be left out? So that will be 70%. So our final concentration of reactant, that will be 0.70 R naught. 70% left, that means if initial was 1 R naught, then final will be 0.70 R naught. So let's cancel this R naught and you are left with 2.303 multiplied by 77.78 divided by 0.6931 into log of 1 upon 0.7, or you can write it 10 divided by 7, and now you will use the numbers given in the question. So this is 2.303 into 77.78 divided by 0.6931 multiplied by log 10 upon 7 can be written as log 10 minus log 7. So log 10 is given as 1 minus log 7 is given as 0.8450. Now let's put the values and solve this. 40.058, or you can write 40.06 minutes. So this is the answer. It will take 40.06 minutes for the reaction to get 30% completed. So this was one of the questions given in part 4, but there is one more choice in the part 4, A or B. So this was part A. Now let's do the part B. So this was part A of the fourth part, and now we will solve B also. So it is in choice, so you will either do A or B, but let us see both of these. So part B of the question says a first order reaction has a rate constant 1 into 10 to the power minus 3 per second. How long will 5 gram of this reactant take to reduce to 3 gram? And log 3 value is given 0.4771, log 5 is given 0.6990. Okay, so let us write everything. So rate constant is given as K is equal to 1 into 10 raised to the power minus 3 per second, and you have initial concentration is 5 gram and final is 3 gram. So you will write initial concentration R naught as 5 gram and final concentration as 3 gram. They have also given you log 3 is equal to 0.4771, and they have also given log 5 is equal to 0.6990. Log 5 is equal to 0.6990. Okay, again we will use the same expression for first order reaction. So you have to calculate the times. You will write T is equal to 2.303 divided by T, and it will be log initial concentration of reactant upon final concentration of the reactants. Let's put the value 2.303 divided by, sorry, here it will be K not T. Here it will be 2.303 upon K, which is rate constant of the reaction. So K will be your K is given in the question 1 into 10 power minus 3 into log of R naught is 5 divided by R is 3. So let's put the values and solve it. So it is 2.303 into 10 raised to the power 3 into log 5 minus log 3. So log 5 is given as 0.6990 minus log 3 is 0.4771. And if you solve this, let us see what we get. 1 seconds. So the reaction will take 511 seconds to complete, or not complete, but it will take 511 seconds for the reactant concentration to decrease from 5 gram to 3 gram. Okay, so that's the answer, 511 seconds. So I hope you understood this question, and this is a nice question. We did all the parts of it. So if you have doubt, you can ask the questions in the comment, and I would love to answer those questions. And if you like my videos, please consider liking these videos and subscribe my channel also. That will motivate me to make new videos. So thank you very much, students. Take care and bye.